Can y'all hear me in the back of the room?
On?
Okay, thanks. So, thanks, Amy, for the opportunity to come and visit with you today. Most of what I'm going to be lining up is kind of Lake Erie focused. And actually, is everybody in here crop advisors or what kind of, any farmers, any regulatory people, any researchers, any, let's see, what did I leave out? Anybody else? All right. Facility, but one back to this ideas with some things that are going to bring a lot of Watershed. This idea actually came to us from a crop consultant that has tens of thousands of acres worth of land that he's helping to manage. And he's noticed changes in soil pH, changes in, there seem to be fewer phosphorus deficiencies in the Lake Erie region. But those phosphorus deficiencies kind of and we see more sulfur deficiencies. And he's kind of related that to things that have gone on with acid rain. And over the same period, we've seen increases in the soluble phosphorus Erie causing some algae blooms. So I got to give credit because we're trying to look at nitrogen or fertility, but we got man-made issues that are really the primary driver in some of these fields in terms of compaction differences. It's not the fertility issues. So what I was asked is, are changes in rainfall chemistry linked to increased phosphorus availability or phosphorus loss? An alternate title might be, is the Clean Air Act messing up Lake Erie or your favorite water body? Or anybody remember Milli Vanilli? Alternate title might be Blame It on the Rain. Yeah. So just to give you the setting, so the Great Lakes represent 21% of the world's freshwater supply, 84% of what we have in North America. Lake Erie is the smallest. And make decisions. It's the shallowest of the Great Lakes. Most agriculture in its contributing area. Tourism, just in Ohio, of Lake Erie represents about $7.5 billion for that industry. About another $1 billion in trade through the ports. The port of Toledo is the second busiest port on the Great Lakes. And they have a 14-mile channel that the Army Corps of Engineers has to keep open because that end of the lake is so shallow that most ships can't move through there without keeping that open. So I think they spend on the neighborhood of around $5 million a year in dredging to keep that channel open. They've gone from about 1,200 charter boats in about 2000 to just under 800 as of a couple of years ago, because of a drop in information on how people don't want to go spend their hard-earned dollars fishing in a green lake. A guy named Jeff coined something called the 50 and 2 rule. But there was high-risk fields and low-risk fields, and we were doing that all by data in 15. And finally, we're getting into some high-risk selection caught in the Great Lakes. Only about 2% of them come from Lake Superior. Lake Erie has about 2% of the water, but about 50% of the fish are coming from Lake Erie. So here's the lake in one of the big algae blooms. You can see it's pretty extensive. So as point of reference, this is Toledo, and this is Cleveland. So pretty much the entire coast of Ohio was covered in this algae bloom. And we separate the lake into thirds. So from this point east, we call or west is the Western Basin, Central and Eastern Basin. And most of the problems are happening in this region. So extent of algae blooms, the number one thing we can link it to is the amount of total phosphorus loading over the year, the amount of soluble phosphorus loading over the year, or specifically the amount of soluble phosphorus loading during the spring. Whenever we look at this on an annualized basis, we see that it's between 1 and 1.25 pounds of phosphorus leaving through the mouths of these rivers on an annualized basis. So,
It's at minimum.
and
The $10
then
about $1 per flight. That starts from the growing season,
and it's only a pound per acre, so,
post harvest, depending on one flight.
but
But that just tells you, I know that's money.
logical impact. And most of the
How we can be a little bit smarter and
is fertilized with commercial fertilizers, so MAP or DAP. So if you take 100 pounds of DAP applied every other year, because we're corn bean rotation, most of the guys put on DAP
availability and the price of
corn. So that's 22 pounds of elemental phosphorus that they add every other year. So you take this that's being lost,
acre per flight. So don't
2 pounds lost of that 20
$20 an acre.
applied. Now that's some gross back of the napkin calculations, but about 2% of what's being applied is, or 10% of what's being applied is lost. That's really oversimplification, but we think the bigger problem is a shift from less of that phosphorus being soluble to we've seen an increase in the soluble phosphorus loading. These algae blooms are also releasing toxins. I know that's really hard to see there probably because a lot of these are in black, but this is toxins that we know of. So it goes everything from ethylene glycol there, which can make you pretty sick, it can kill you, to dioxin. Everybody's heard of dioxin, right? The next thing on this list is called microcystin. One of the primary algae in that algae bloom is called microcystis. It releases
$100.
a toxin called microcystin, and it's next in line to dioxin. Of the top 7 toxins that we know of, 4 of them are algal toxins. So I worked in the Lake Erie watershed for about a dozen years. I moved to Texas, which is a move home for me, in June of 2014. I turned on the news August the 2nd, I think, which was a Saturday of 2014, and this was what was all over the news. They had shut down Toledo's drinking water because that microcystin was detected in their polished drinking water at levels above what the World Health Organization says is drinking.
No.
So also you have half.
And so I want to talk a little bit about and so
We've gone from, green algae or people don't want to spend their tourism dollars, so it's a nuisance to. And this is 2 months after I moved, so I claim no responsibility. So this isn't my fault.
results or scenarios that's in the field in terms of how the crops develop.
Whenever I show that slide,
Vigor and the health of that crop sometimes can be explained by just having that planter data in-house. Okay? So,
Lake Huron is the next lake upstream, and it accounts for only 4% of the phosphorus loading to the lake. It's interesting that we get more atmospheric
basic
position into the lake
go through on every
than we do coming from the upper lakes.
thing.
We have the National Center for Water Quality Research at Heidelberg University, which is a local university, and they monitor most of the water flowing into Lake Erie. And they know that about 52% of the phosphorus coming into the lake is through those monitored tributaries.
Especially when we're doing splits.
There are other rivers through some different exercises. About 20% of the phosphorus comes from those rivers. And then we have some other sources. But by and large, 70% is coming
All the terminology
from rivers. So it's made
I don't know how much
algal blooms in the 70s.
okay, if your planters
were well known in the popular culture. Johnny Carson joked that Lake Erie is a place where fish go to die. And then we have
cases.
has anybody read the Lord Act with your kids? I'll just let you read this. I don't want to insult your intelligence and read it to you, but you know, Lake Erie in the 70s and 80s was known as
It's that field when I go out there. Got some corn and V5 over here.
the impetus for passing the Clean Water Act. And it was really held up as a success story, the Clean Water Act in the 90s and early 2000s, because we'd cleaned up the lake, it wasn't green any longer, we had expanded tourism, everybody wanted to come to Ohio and fish. And as part of the Clean Water Act, so this is on the left, this is the total phosphorus loading dating back to, I think, 1967. And they set a target through the Clean Water Act and a binational agreement with Canada. We only need 11,000 metric tons of phosphorus loading to the lake, which we achieved. Phosphorus is causing part of the algae blooms. We know that. Let's set a target. We hit it. The lake cleans up. Everybody's jumping up and down. We did it. We did it. Stretching themselves out of shape, giving themselves a pat on the back. And then in 2002, there was a little tiny algae bloom. Everybody, well, that'll happen every now and again. 2003, it was a little bit bigger. 2004, bigger. And it kept growing until the algae bloom in 2011 and 2014, which were real problems. On the right here, we see the soluble phosphorus loading. And it's come down from the mid-1970s, which is right here, and kind of reached a minimum in the mid-1990s or early 2000s. It kind of depends on which statistician you ask as to where this minimum occurred. But over the recent years, the phosphorus loading the lake is still kind of flat. So we've done a good job. That was done through point source reductions. There have been tremendous efforts in, encouraging no-till, grassed waterways, all the conservation practices that are put on farms to reduce sediment and phosphorus, right? But now we have this divergence in soluble phosphorus and total phosphorus. And it's this soluble phosphorus that the algae can grab real quick, right? And so a colleague and I toured the state, and after this shutdown of the drinking water, we sat down and we wrote out, I think, 26 different causes that we'd heard from different groups. Can anybody guess what some of these causes are? Manure. That's the number one. Everybody would sit down and say, well, it's the manure. It's got to be the manure. Only about 15% of the phosphorus in this watershed goes on as manure. So that doesn't make sense to me. Anybody else? People were blaming wastewater treatments. We didn't include that in our list because we were trying to limit it to predominantly agricultural sources. Laundry detergent has largely been solved because they've taken out the phosphorus in the laundry detergent. There are 3 additional ones that we've heard based on this, and I'll give you 2 of them right now. My colleague went with a large equipment manufacturer and sat down. It was right after we submitted this as a paper, and the equipment manufacturer said, well, we heard it was George Bush's fault. Seriously, that's what they said. And I know George Bush is blamed for blowing up the levees in New Orleans and everything, but I don't remember seeing him out there dumping phosphorus into the lake. And another one was, well, we heard there was a barge full of phosphorus that sank in the 1970s and it's finally releasing phosphorus. To our knowledge, that's not true either. But here's the list. What I'm going to talk the most about today is the Clean Air Act. And as I opened the talk with, this idea came from a crop consultant who's noticed changes in soils. He's noticed changes in crops that coincide with changes in water chemistry, that coincide with changes in the atmospheric chemistry, really. There's a lot of other things on this, and I'd be happy to talk about any of these if we have time later on.
The yield comes out.
But everything from the way our rental agreements are structured to glyphosate. People are blaming the ethanol plants. So lots of different things. And I think in reality we have a perfect storm of everything kind of coming together to cause this. So I'm not willing to say that there's one cause on here. I think it's all of them contributing just a little bit. I'm going to take a step back and look kind of at the 80,000 foot level. This is a really complicated graph, but we have seen shifts in the phosphorus concentrations in lakes and streams on a continental basis in the US as well as in Europe. So on this graph we have total phosphorus on a log scale on the bottom. So what this means is, so in 2000, 50% of the streams had a phosphorus concentration of about 20 micrograms per liter. Okay. Let's go to 2014, which is the green line. 50% of the streams had a phosphorus concentration of around 4 or 5 milligrams per liter or less. So we have seen a shift, and whenever we look at that on a map, so the darker the color, the greater the increase. This is predominantly in pristine systems. You notice what goes on in this part of the country? Agriculture. So there are pretty much no pristine streams or rivers in that part of the world, right? So this is really pristine systems, and they've noticed total phosphorus increases where there aren't really anthropogenic inputs of manures or commercial fertilizers, things. Now they didn't separate out the total phosphorus from the soluble phosphorus, so we don't know if this is particulates getting into the water, or maybe like we've seen in Lake Erie with increased soluble phosphorus loading, maybe the particulate loading is staying the same, but it's the dissolved component that's gone up, which has pushed up the total phosphorus. We don't know, so we can't really speculate on exactly what the mechanism is of this. Here's the sulfur deposition across the U.S.
You look at
Castile
probably maybe some
talk on Tuesday. I talked with Sean some yesterday, and they've started seeing sulfur deficiencies, same as my crop consultant friend. In 1989, before the implementation of the Clean Air Act, you know, we had a lot of sulfur deposition in this part of the world. So, done a good job of cleaning that up, right? But has maybe the law of unintended consequences shifted some things? I have some friends that are stream ecologists, so they like to dance around in streams and look at food webs and all this stuff that doesn't really matter to farmers. This is a really complicated graph. I don't know why stream ecologists think they have to make everything so difficult. But we have the change in the sulfate concentration of the rain, and the change in the dissolved organic carbon in the stream. So the dissolved organic carbon is important to stream ecologists because it tells them about what's going on in the food web of the stream and what's going to happen to the different communities and different things. So we've decreased the sulfate concentration in the rain, right? So we've moved in this direction. So if you cross your eyes and spin around 3 times till you're dizzy and look at this graph, what happens is you decrease the sulfate concentration. You increase the dissolved carbon. So could there be a link with dissolved phosphorus. I'm not entirely sure yet.
I know what we use.
Some more data. So sulfate in the rain. Here we have the pH of the rainwater. It's kind of increasing there. And dissolved organic carbon in streams. Kind of the same trend we see there. So there's a network of that monitor
Together.
precipitation chemistry in the U.S. And I looked at rainwater from 1990, which is when the Clean Air Act just about started. And the pH of our rainwater right at the top end of the Maumee River, which is major tributary to western Lake Erie, was 4.4. In 2011, which is when we had that really big bloom, it was 5.1. Now, that's not quite a single pH unit increase, but it is pretty significant. Sulfate has been cut in half. Nitrate in the rainwater has been cut almost in half. So just a conceptual diagram. I'm not going to say this is exactly what's happening, but just in the milliseconds of when a raindrop hits the soil, maybe what's happening here. So if we look at the phosphorus availability, that rainwater in 1990 versus 2011. Now, pH is down below 6. What's controlling the chemistry of phosphorus? Sorry? Yeah. So iron and aluminum are controlling phosphorus at that pH, right? So, and what we had in 1990, it was a little bit more controlled by aluminum and iron, right? So we did some experiments in the lab. I took 8 soils from Ohio and Indiana. And we mimicked rainwater from 1990 and 2011. In 5 of the 8 soils, we saw increases in the soluble phosphorus comparing the rainwater from 2011 to 1990. So that's pretty intriguing, right? But in 3 of the cases, we saw decreases. So nothing really conclusive here. Maybe something going on, maybe not. What's happened with our fertilizers in the last 20 or 30 years? Switched from triple superphosphate to MAP or DAP, right? pH of triple super, pretty acidic. DAP, about 7.5. Let's go back to that kind of conceptual. Well, let me back up a second. So we extracted, let's see, we got 6 different fertilizer sources. So just kind of threw the book out there of what's going on with fertilizer sources, making the assumption that we don't till our fertilizers in the soil anymore. So what happens if you fertilize, that fertilizer prill is just sitting there and then you get rain on it. So we extracted these fertilizers with those 2 rainwaters. And in every case except for rock phosphate, we got increases in extracted by 2011 rainwater chemistry. So back to the conceptual diagram. In 1990, if we were using triple superphosphate, that rainwater hits, the millisecond it happens, if there's any iron or aluminum in the system, then it can grab phosphorus really quick. In 2011, when we fertilize with DAP, that's the switch of phosphorus availability for pH. So,
because it wasn't incorporated. And all of a sudden, they cannot provide us.
Yes, sir.
Did you overlay total rainfall on various years from say 90 to 2000?
Well, right now in the lab, we're trying to piece out, is it the pH
Need to use to define zones and drive a lot of the precision nutrient.
change in sulfate concentrations? Is it
as a data layer requirement for these data services in the state of Ohio at least.
So we're trying to piece all this out, and unfortunately I don't have that data available yet, but yeah, it's a really interesting question. Have any of y'all heard of the Haney test, or H3A? Okay, it's been mentioned a few times this week. So I happen to work just down the hall from Rick Haney, who developed the H3A.
Solution of the
So here we have his first iteration of the H3A, the second iteration, the third iteration, and now he's on to the fourth iteration of it. And what he's using is small chain organic acids to extract phosphorus. The reason he uses that is he says that's what the plants exude by their roots in order to extract phosphorus. So I'm not going to make a pitch for or against it, but I want you to look at his pH initially was 5.5. The solution was a little bit buffered, but he's going down in the concentration of a lot of these each time he amends it, and the pH is going down. So I think he took, forget the number, maybe 200 soils and extracted them with all three of these extracts. So on the next slide, it's going to be his H3A, number 1, 2, or 3.
For our providers, service providers using yield data,
Kind of the
state of
standard in phosphorus availability,
out here, but
called the iron aluminum impregnated strip.
like a minimum.
These black circles are when he extracted it with a pH of 5.5. This is the pH 3.8 and the pH 2.7.
I feel is you have some.
You know, this is a little bit separate, but, you know, there's more changes there than just the pH. You know, they're changing the concentration. It's less buffered system, so
Right, and just kind of go along with.
don't want to say that this is only a pH change that's causing increased phosphorus extraction. But, you know, it's just kind of another line of evidence that maybe something's going on. Gave a talk last week to all the people in the ivory tower, and our session was on what's going on with non-growing season phosphorus losses. So on these graphs, it's going to be the red line, and that's all I want us to focus on right now. In the growing season, not only do we get the crops growing, but in the streams, what happens? The algae like the same growing conditions as the plants, right? So if you go by in the middle of December, you're not going to see the filamentous algae growing in the stream. You're not going to see algae growing on the rocks or the cystonic algae that move through the system. So let's just focus on the red line. So this is precipitation pH in the 1990s. Here we have NGS is non-growing season, so pH of about 4.4 for that decade. Moved to the 2000s, about 4.7, and since 2010, we're looking at about 5.4. Okay. Next is going to be total phosphorus moving through the Maumee River, which is the biggest tributary to Lake Erie. So the total phosphorus concentrations. So here again, just looking at the red, we go from 2.7 to 2.7 to 2.5. So it's kind of decreasing. So that's not in line with what we were talking about with increasing phosphorus, right? But it is in line with what we've been saying about kind of leveling off or even decreasing total phosphorus loading, because we've done such a great job with no-till, with putting in grassed waterways, with all these conservations designed to stop the erosion. You stop the erosion, you stop the phosphorus, but you stop the total phosphorus. So whenever we regress the Maumee River total phosphorus against the precipitation pH, it's pretty scattered, and they're kind of declining trends. So this is for the Maumee River and the soluble phosphorus component. So the red line here, in the non-growing season, we're at 45 parts per million. In the non-growing season in the 2000s, we're at 77, so that's
If you don't know,
increased, and it's increased a little bit more since 2010. So whenever we rest those,
I got corn.
we're getting increasing trends, and these are significant. I don't remember the p-value
Corn is
in there,
4, 5,
but there may be a relationship here. And what we as hydrochemists say, a more important variable here might be the soluble phosphorus total phosphorus ratio,
on that.
and these are all significant and increasing. So maybe this increase in pH has something to do with the
The problem
relative increase
is
in
very.
soluble phosphorus.
I mean,
Now, we'll say that these are just correlations, and the number one thing, I would suspect that Amy would agree, whenever you have a grad student come in your office and say, yeah, I got a correlation, this means that this caused this. You have to always get on to them and say, no, that means they're correlated. It doesn't mean that this caused this. It just means something happened and they're both changing at the same time. So I can't infer that the precipitation pH is causing the change in the soluble phosphorus. But we do know that they're happening at about the same time, but it's not the only thing that's happened in the watershed.
but, you know,
And this is the
might want to think of
talking about Amy. So I work with probably the most brilliant hydrochemist in the world, who is England, and we just submitted a paper, should be accepted really soon. So this is for one of the major tributaries. It's the cumulative daily loading of soluble phosphorus. So it's basically if we can scoop up every ounce of phosphorus that comes through this river and just keep on putting it in the same barrel and just measuring, how deep this barrel gets. So up to about 2002, we have a slope that's like this, and all of a sudden something happens, slope of this line increases. Everybody can see that pretty well? We know that there are other things that happen, but it's really, really interesting. She's got some amazing statistical tools that I don't know how to use. But this is the weekly precipitation pH, and the inflection point of when this really started to increase happened about the same time. So just more evidence that something's going on. It does not infer causality, but definitely things are happening at about the same time. What's going on here? This is I've been talking about Lake Erie. Y'all probably care nothing about Lake Erie, right? Because it's, 15, 16 hours away. So I haven't had a chance to look at water quality trends here, but this national network of rainfall monitoring sites, I assume this is just south of the Bay Bridge, right, on the eastern shore. So this is a site called MD13. I'm going to take a wild guess, and that MD means Maryland. So this is weekly sulfate in the precipitation since 1983. You notice about here is when a lot of the clean air regulations started. Pretty big spread in those numbers, right? Get to when we start the Clean Air Act, things might be looking a little bit better. And then we hit the 2000s, things tend to look a little bit better. What's happened since 2010? All those numbers have kind of collapsed. down. And you don't see many values above about 2 milligrams per liter, or 2 parts per million. Precipitation pH on those same samples. I don't have the fancy statistical tools that Helen does, but if I close my eyes and spin around real fast and look, I would say the inflection point here is probably around 2004, 2005. So definitely changes occurring here too. Nitrate is another big component of the acid rain. So here we're looking at nitrate in the rain versus the pH of the rain. Pretty strong correlation there. And this is for sulfate. So as far as rainwater goes, you see the same kinds of things happening here that we've seen in Lake Erie. So I can't conclusively say that what's going on with the rainwater has affected the soluble phosphorus, but these things have been happening at about the same time.
Fine.
We've got this list of 25 other things that we know are happening in the watershed. Do any of these kind of intrigue you? Any questions about these? Glyphosate, that's a real popular one. People love to hate on Monsanto, right? That's everybody's favorite whipping boy right now. So, what you...
This gets a little confusing, but I just want you to try and think, understand what.
So 32 ounces, and I've done this calculation, but it's been a long time. To me, the math just doesn't work out. 32 ounces per acre, I forget what it is. It's like, I think it's on the neighborhood of half of an ounce of, or maybe a quarter of an ounce of elemental phosphorus per acre. And we know that that molecule is pretty tightly absorbed to the soil or to organic matter. So to me, I don't think glyphosate makes much sense. We monitored water at 4 fields and 8 ditch sites in the western Lake Erie Basin. We monitored glyphosate on tens of thousands of samples. The amount of glyphosate that you're allowed to have in your drinking water is, I think, 600 parts per billion. Out of those tens of thousands of samples, I think we saw that twice. It was in the same rainfall event from an agricultural field that had just had glyphosate applied to it. So we don't see it, and we saw, I think we saw detection, just what we can measure of glyphosate in runoff water in less than 1% of the samples. So we eventually gave up analyzing for glyphosate just because it's so cotton picking and expensive. And we rarely saw it. So that's one that's thrown out a lot. I don't have any evidence to support glyphosate being the cause. Now, indirectly, it's possible that it could be. Does anybody know what used to be labeled to control algae in farm ponds? Atrazine. Okay. I think you used to be able to use atrazine too, and we've seen a fairly sizable decrease in the amount of atrazine used in this watershed. Our watershed project actually got started because Fort Wayne, Indiana, which we worked in the drinking water source for Fort Wayne, and they were reported to have the second highest levels of atrazine in their polished drinking water. So, all of a sudden, all the money. So that's why we started our project up there, which happens to be in the Lake Erie watershed. In Indiana, I can show you decreasing trends in atrazine. Now, you notice that's not on this list, but I also said that there were 3 that we've been told that aren't on the list. We eliminated bush, we eliminated the tanker, atrazine's the 3rd one. There may be something to atrazine because we have, in Indiana, we've seen decreasing trends in the atrazine.
I did exactly what was said.
My colleague Kevin King has the same data that he can show for Ohio, so it's possible. I don't know that the concentrations that we see in the streams are enough to inhibit algal growth because they're pretty low. The amount of atrazine that you're allowed to have in drinking water is 3 parts per billion. And
Yield scenarios in that field. That kind of makes sense. Kind of digests. I'm assuming it's going to be
10% or less of the samples that we saw were above that 3 parts per billion. So I don't think that the concentrations are there, but indirectly there may be a link with the glyphosate, but it's because we replaced atrazine with glyphosate. I mean, we have definitely made tremendous strides in air quality, and I have some friends that used to work up in that area, and we can trade stories about what's going on. I'd rather not be recorded.
What about the combination of tile drainage and no-till?
That's a really good point. So let me see if I can. Okay. I added some extra stuff because I didn't know if y'all were going to interact. So here's some data from. So in Indiana,
flying.
we had fields that were tilled, they were in never till, and then we had a rotational till. A lot of farmers in the region say no till, no corn. So a lot of them use this rotational till. So they'll till their bean stubble to go into corn. So this is my data. It's a science nerd graph. Sorry about that. But here we have the till for soluble phosphorus and the till for total phosphorus, and here's the no-till. Notice that the till for soluble phosphorus is less than the soluble phosphorus from the no-till, and the total phosphorus, same thing. How that happened, I'm not entirely clear. This is from some data from Ohio, from Kevin King. He's got no-till, rotational till, and tilled every year. So tilled every year, soluble phosphorus is lower than the no-till, total phosphorus less than a no-till. There are a lot of other things going on, but there could be something.
Leader yield monitor components, or even precision planting. The way to get over this is there is a box in one of your menus on your display that you can go to and look at pounds per second. And what I encourage you to do is as you go to the speeds or change your speeds, the important thing is look at your pounds per second, not the
See. So drainage,
pounds per second, and seeing what range you're covering, because that will be the
evapotranspiration. You can see
that one number right there. But there is
we have everything from what we call the
second. If you're concerned about quality yield data, all you got to do is do this one time. One time, assuming I don't re-maintenance.
drain
Once I've got that fully for each crop, each scenario,
water.
I'm good to go.
Yep, this is the spot I was looking for. So I think these are all no-till fields that Kevin King has. The soil
Here's what you don't
about 2 inches.
talk today a little bit on remote sensing, but primarily on planting data, yield data. Hopefully you kind of look at these yield monitor data just a little bit differently in terms of presented. Something to think about, challenge you with. But I think the ability to measure things, have information at your hand.
Our peak discharge, we measure discharge every 2 minutes with our auto samplers. Our peak discharge in the surface happened within 4 minutes of our peak discharge in our tile. So there is a direct connection, and it's through macropores. You can see these
So the question,
from this. It's
when I go to
very, very common, especially in our no-till fish.
facility,
Does that answer your question? So there is a link there, how we get around it.
that's a very important ingredient when you do this. So if you're whatever speed, 2, 3, 4, and 5, you want to maintain that. I know in heavy or high yielding conditions, 5 miles an hour is
It's quite the quandary. Let's see. We have seen a shift in the timing of precipitation, so we seem to be getting more spring rains, which coincides with when we're putting on fertilizer and when the critical times are for that phosphorus loss. So, is there anything else on that list that you guys had questions about?
No, where do we go from here?
It's a good question. I don't know. So we went to probably a dozen meetings over a 2-year period with the Great Lakes Commission and NRCS, and everybody wanting us to tell them what one practice to put our money in. And they were wanting us to say, oh, cover crops is going to solve everything, right? And the evidence, especially with soluble phosphorus, is if you put cover crops on, you're probably going to increase the soluble phosphorus. So if your resource concern is soluble phosphorus, cover crops is not the answer. It's wonderful for other resource concerns, for total phosphorus, erosion, nitrates, but not for soluble phosphorus. This is such a hairy beast that we just don't know how to tackle it yet. Limited tillage, getting the fertilizer in contact with the soil, using the right rate, the right time, all the 4 R's stuff. There's
3,000.
it's more of a fertilizer management and a source management.
Does that answer your question? Any other comments, questions? Well, thanks again for the opportunity to be here and
Of our tile. So let's see. In conclusion, these things are happening at the same time. Doing those extractions, it looked like there might be a link, but we've had so many other factors change. We can't confirm that this precipitation chemistry is the problem, but we can't exclude it either. So I think that's my time.